In this video, we are going to cover linear versus nonlinear functions. Let's begin. So a linear function is a function that will make a straight line when it is graphed. Pretty simple, linear line. Straight line, specifically. All right, continuing on. An equation is linear if it can be written in the form of y equals mx plus b, where m is the slope and b is the y-intercept. And remember, the slope is the steepness of the line. The y-intercept is where, for example, if this is a graph, the y-intercept is where this line would touch the y-axis. And remember, this is a y-axis right here. It goes up and down. So the y-intercept is like this point right here where our line touches the y-axis. And also, a table is linear if it shows a constant rate of constant rate of change throughout the entire table. So we're analyzing linear functions in a graph, an equation, and in a table or set of ordered pairs. So in the following examples, we'll use functions to fill out a table of values and create a graph. Look for any patterns among the functions that are linear and those that are not. So we've got our equation, we've got our table, and we've got our graph. All right, so what they want us to do is figure out, well, they've given us an equation and they've given us a table to fill out our information. So if x is -2, what does y equal? You know, I'm going to start with 0 first. If x is 0, what does y equal? So x is 0. If I add 0 plus 1, so 0 plus 1, that would equal 1. If x is 1, that'd be 1 times 1, which is 1, plus 1, which is 2. If x is 2, then x squared is 4, and 4 plus 1 is 5. If x is -1, -1 times -1 is still 1, and plus 1 is 2. And if x is -2, -2 times -2 is 4 positive, and 4 plus 1 is 5. All right, let's graph this. When x is 0, y equals 1. So it starts right there. When x is 1, y equals 2. When x is 2, y equals 5. And then it goes on the other side as well. When x is -1, y is 2. And when x is -2, y is 5. Huh. So you've got this kind of strange thing. This is called a, these are parabola. There it is. So that's actually what our graph looks like. It starts curving upward. Is this function? Well, it is a function. Now, is it linear, y or y not? It is not. Not linear. Why not? Not a straight line. So it is not a straight line. Let's take a look at the next one. Y equals 1/2 x. When I'm going to start with 0. When x is 0, y is also 0, because 0 times 1/2 is 0. 1/2 times 2 is 1, and 1/2 times 4 is 2. 1/2 times -2 is -1, and 1/2 times -4 is -2. And you could figure this out on a calculator by just putting 0.5 times whatever this number is. So let's graph this. 0, 0, 1. So when x is 2, y is 1. X is 2, y is 1. X is 4, y is 2. When x is -2, y is -1. X is -4, y is -2. So it looks like it's making a straight line. I didn't do a very good job of drawing that line, but it's okay. Is the function linear? Yes. Line is straight. the line is straight. We could also add some other information about the graph as well, namely that the table shows a constant rate of change. So let's look at the table real quick. How do I know the rate of change? Well, let's discuss the rate of change. So we know how to do it with the graph. The line isn't straight. So the line isn't straight, so that's why it's not a linear function. But with the table, if I didn't have this graph, how would I know if it was linear or not? Well, let's look at the rate of change from this one to this one. You add 1, right? From that to here, you add 1. From here to here, you add 1. From here to here, you add 1. You're adding 1 each time. And then the rate of change from this point to this point, you're going minus 3, right? And from here to here, it's 2. How do you get 1? You subtract 1. And from here to here, you add 1. And from here to here, you add 3. Notice what's going on with my rate of change. The top just changes by 1. The bottom is changing by like -3, -1, +1, +3. So this rate of change is going all over the place. Whereas if I look at this one, let's take a look at all these. From -2 to -4 to -2, that's adding 2. And you're adding 2 more, and you're adding 2 more, and you're adding 2 more. On the bottom, what is my rate of change? From -2 to -1, I'm just adding 1. Then I add 1. Then I add 1 again. Then I add 1 again. Notice the rate of change. It's like 2 to 1, 2 to 1, 2 to 1, 2 to 1. Or actually, you do y over x, but 1 to 2, 1 to 2, 1 to 2, 1 to 2. Rate of change is constant. So you might want to write that down as well. Rate of change is constant. Which goes, sorry. For this one, it's definitely not constant. Rate of change is constant in this one. What do you notice about the that is different about the functions in question 1 or 2? Well, there are a couple things. Number 1 had an exponent. For number 1, x had an exponent, or power change. The other thing, number 2, no exponent. So something you may want to know is if you see an exponent anywhere in the equation, then you'll know that it is not a function. So if you have a graph and it's not a linear function, so it's not linear. So this is not linear. It has a function, or it has a exponent, which will end up curving the line. This one has no exponent, either on the y or x, so we will not have curved lines. So basically, if you see an exponent either on the y or x, not a function. Or sorry, not a linear function, not linear. Goodness gracious. Let's go with this. Already you can tell number 3, not linear, because it has x raised to the 3rd power. But let's go ahead and fill out our table. When x is 0, y is also 0. X is 1. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. -1 times -1 times -1 is still -1. -2 times -2 times -2 is -8. So what does this look like? 0. At 1, you have 1. At x is 2, y is 8. When x is -1, y is -1. And when x is -2, y is -8. What does this actually look like when you graph it? It's actually a curve. Kind of goes like that, and it curves downward like that. Now, technically, this is a function because it passes, well, if I draw a vertical pencil, there you go. If I do this thing, it does pass the vertical line test. Look at that. But the question is it linear? It is not linear. You would say no. If you're asked why it is or is not linear, there are a couple explanations. Graph isn't straight. Line isn't straight. IGHT. You could say table shows a different rate of change. So from here to here to here to here to here to here, you're adding 1 each time for the x's. And for the y's, it's like you add 7 and then you add 1 and then you add 1 again and then you add 7 more. So it's just kind of a weird rate of changes. You would call that a variable or a changing rate of change. Rate of change, not constant, not constant. And then you could say x to the third power for the equation. All right, next one. Let's look at the equation. Can we tell whether or not it's linear from the equation? Well, is y or x raised to any power? No, it's not. So it's probably linear. Now, there are other things that can mess it up. For example, like if you have well, there are different ways, like if y is an absolute value, but we're not going to get there. So far, it's looking promising. Let's put some numbers in. When x is 0, that's 0 times 1.5 is 0, plus 2 is 2. 2 times 1.5 is 3, and 3 plus 2 is 5, and 4 times 1.5 is 6, and 6 plus 2 is 8. Negative 2 times 1.5 is negative 3, negative 3 plus 2 is negative 1, and negative 4 is negative 6, negative 6 plus 2 is negative 4. All right, let's look at our graph. So if I graph 0 and 2, when x is 0, y is 2. When x is 2, y is 5, which I guess is over here. And when x is 4, y is 8, which is right there. When x is negative 2, y is negative 1. Which is right there. And when x is negative 4, y is negative 4. So is it a straight line? Yeah, it kind of looks like it is a straight line. Is it a function? Oh, is the function linear? Yes. Why is it linear? Straight line. Straight line. Let's look at the rate of change. From here to 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 here. It looks like it's just adding 2 each time. Yep, from negative 4 to negative 2. Yep, plus 2. And from down here, let's see if the constant rate of change. Let's start with the positives. 5 to 3 is plus 3. 2 to 5, is that plus 3? Yeah, it is. Negative 1 to 2, yeah, you add 3. Negative 4 to negative 1, yeah, you add 3. You get to negative 1. So, constant rate of change. Constant. ROC, I'm going to call ROC for rate of change. And finally, no exponents on variables. All right. Number 5. 12 over x. Well, let's do the table first. Can you tell from here? Well, x it's a denominator. So if x is a denominator, let's see. 12 divided by 1 is 12. 12 divided by 2 is 6. 12 divided by 3 is 4. 12 divided by 4 is 3, and 12 divided by 6 is 2. Let's graph that, see what that looks like. When x is 1, y is 12. When x is 2, y is 6. When x is 3, y is 4. When x is 4, y is 3. And when x is 6, y is 2. So if you look at this, it does not seem to form a straight line. Technically, actually, this is what your graph ends up looking like if you keep plotting all the points. Is the function linear? No. So if you have x as a denominator, also will not work. This is also technically x to the negative 1 power. Anyways, if x isn't to the first power or y isn't to the first power, it's not linear. Let's look at the table and the rate of change on the table. That's plus 1. This is also plus 1. 3 to 4 is plus 1. So far, so good. 4 to 6 is plus 2. All right, whatever. 12 to 6 is minus 6, and 6 to 4 is minus 2, and that's minus 1, and 3 to 2 is minus 1. Weird. So your rate of change is like -6/1 and -2/1 and -1/1 and -1/2. So rate of change is not constant. So is the line straight? Not straight line. So line isn't straight. Line isn't straight. Rate of change not constant. ROC, not constant. And finally, if we look at the equation, x is denominator, which is not good. What difference did you notice about the equations that were linear functions and those that were not? Y and x for those linear and non-linear equations is raised to an exponent. Of linear equations are not exponents, aren't. Exponents are denominators. Denominators. And then what differences did you notice about the tables that were linear and those that were not? Tables with constant rate of change, ROC, were linear. Not constant ROC are not linear. Non-linear. And so that's that. How can you tell whether a table, graph, equation, or even set of ordered pairs forms a linear function? And remember, the key here is whether or not it is linear versus nonlinear. For equations, remember, if you see any kind of exponent or x as a denominator, or same goes for the y, it is nonlinear. It won't form a straight line anymore. For tables, you should look at the rate of change, which is from here, from the bottom. And if the rate of change is constant, like -3 to 1, if it's all -3 to 1, then you're good. But this goes from -3/1 to -1/1, which does not equal the same thing. This one, 1/2, 1/2, 1/2, 1/2. You sometimes may see 2/4, but 2/4 means 1/2, so it is constant. And then for your graphs, it's easy. If it forms a straight line, then it is a linear function. All right, go ahead and try some problems on your end, answer some questions. Good luck.